After learning the previous two parts, I'm sure you guys have got some knowledge of the basic development procedures of Ruff, how to add a device, and how to refer to its usages. In this lesson, I'll use a more complex integrated case to consolidate what we've learned before. In this lesson, we'll realize a smart light. If under an environment of bright light, the light automatically goes off. When under dim light, the light automatically lights up. In hardware preparation, in addition to the Ruff development board, we also need, from the development kit, the relay module and the light sensor module. Besides them, we also need an extraordinary electric light, which is for domestic use, operating at a voltage of 220 volts in China. A plug adapter for lamp holder is also needed, with a switch on it, to control it on or off. Some necessary tools and materials are also required. To realize the smart light, in fact, the most crucial part for us is to control this electric light with the relay. Well, as for the relay control, one of its capacities is to control strong current through weak current. A weak current, here we mean the 5 voltage or 3.3 voltage on our development board. And a strong current here means our domestic purpose 220 voltage in China. Then what is the principle of relay? As we hear in the left diagram, the relay actually has 3 external pins, which are the normally open No pin, the command terminal COM pin, and the normally closed NC pin. Inside it, there is a mechanical switch. When we say the relay is in a closed status, we actually mean that the switch has its normally open and common terminal short-circuited. After being released, this switch will short-circuit the common terminal and the normally closed terminal. Next, we need to change this light socket. Here's the diagram of light socket. As we hear in the left diagram, it is actually plugged to a power supply with both ends representing the zero line and the live wire, respectively. In fact, this socket has a switch to control its connection or disconnection. What we need to do is add both sides of the switch lead out and wire. As for the completion effect drawing, we may look at this. The tested capacity is, if this switch is in open status, which means the two are not closed, after I short circuit these 2 external wires, the switch can also be in an on status. After we learn about the relay principle and how to change this light socket, we will connect the 2 wires of light with the relay. Let's connect the 2 wires to the normally open and normally closed terminals of relay, respectively. When we control this relay and it is in the closed status, we actually connect the 2 wires. Upon connection, the light can be properly lit up. When I control this relay to be under a released status, I will short circuit the common terminal and the normally closed terminal. So the 2 of light wires are disconnected and the light will be under a closed status. After we have prepared all the hardware, we need to prepare a software Ruff application. First, like what we did before, we need to create a new project and add 2 devices. The 2 devices are the relay module, whose model is Relay 1C, and the light sensor module, whose model is GY3. I named them Relay and Light, respectively. Here, we may call the device in our application code, and then generate the layout and finish connection. Most importantly, we need to write its business logic. First, we need to determine such a boundary. When we acquire the luminance of sensor, it actually returns us a numeric value, and its unit is lumen. So we need to define a boundary value here. Let's suppose it is 100. If the return value exceeds 100, we would think that the light sensor is under an environment of bright light. If it is less than 100, we would deem that it is under an environment of dim light. Also, we need to set the period of acquisition. Here we set it as 1 second. If we set that the sensor acquires a numeric value every 1 second, and if it is less than 100, the relay is turned on. To turn on the relay is actually to turn on the electric light. If it exceeds 100, the relay is then turned off, for example, to turn off the light. As for its code, we may look at this diagram. Here, I've completed the code. Let's have a look. First, we call this set interval, and its time interval is 1 second. Whenever we enter this callback function, we need to call this light such a function to acquire the sensor. And this function will return us the most important value, which represents the illumination intensity. And we will judge if it is less than or equal to 100, we turn on the relay, or to turn on the light. If it exceeds 100, we turn off the relay, or to turn off the light. That's the entire logic. After that, like we did in our previous 2 lessons, we'll first configure a network environment and then use Ruff deploy s, such a command to deploy the app onto the development board for running. As we see, its effect is like this. When the surrounding environment is bright, the light will turn off. When the surrounding environment is dark, the light will turn on. Alright, so that's all for this lesson. So please look forward to our upcoming classes on Ruff. Thank you very much. Ruff, make IoT easier.